Part 3, common factors of a polynomial. Recall that a polynomial takes the form of any group of numbers and letters together in a single expression. So let's look at some examples and discuss some terms like coefficient term, constant term, like terms. Okay, so let's start with this. If you have the polynomial 3x plus 5, okay, this is called a binomial. Binomial because there's two. So binomial. Wow, that's terrible writing. Binomial. Okay, this guy here, he's called the constant term. And he's called that because he's got no letters on him. Okay, so constant term. Oh, by the way, yeah, binomial, there are two terms here. Terms are separated by plus or minus signs, okay, or equal signs, I guess. So look, 3x plus 5, okay, so that's binomial. There's two terms. 5 is the constant term. 3x is called a variable term, okay. That's not that important, but a variable term just has a variable in it. Okay, in this guy, the 3, the number in front of any letter is called a coefficient. Coefficient. Okay, if that coefficient happens to be on the term that has the variable or has the largest exponent on the variable, it's called the leading coefficient. So in this case, this is the leading coefficient. It's the only coefficient. Okay, so that'll be more clear when we get bigger terms, or bigger nomials. But anyways, so that's it. Constant term, coefficient. Okay, it's a leading coefficient, and that one is a binomial. Okay, so let's draw another one. Okay, so if we have 4x squared plus 5x minus 4 plus 3x. Okay, so right now, how it's written is there's 4 terms. But see how that's a 5x and that's a 3x? Those are considered like terms. They have exactly the same variable with exactly the same exponent, so they're friends. They combine, they play together. Okay, so plus 5 and plus 3 makes plus 8. So this simplifies to 4x squared plus 8x minus 4. Okay, so now see there's only 3 terms, so this is called a trinomial. Okay, 3 terms, trinomial. Okay. The 4 is the constant term, right? No variable on him. Now, the 8 is a coefficient. The 4 is a coefficient. Okay, so that those words still apply. Now, see how the 4 though is on an x squared. Okay, the 8 is on an x to the 1. So the highest exponent is x squared. So this is called the degree term. The degree is the highest exponent, so degree 2, okay, degree term, okay, and then the 4 is then called the leading coefficient. The leading coefficient, okay, not a big deal, okay, awesome. So negative 4 is the constant, 8 is a coefficient, but 4 is the leading coefficient. Awesome. Okay, so that's a trinomial. So look, if you just have something like 5x, this is called a monomial. Monomial. Okay, there's no constant term. The 5 is a coefficient. It's the leading coefficient. Okay, so no constant, monomial, just 1. Okay, now of course you can have stuff like this, 5x cubed plus 4x squared minus 3x minus 2. So the constant is minus 2. Okay, the leading coefficient is 5. The degree term is 5x cubed. Okay, the degree is 3. Remember, degree is the highest exponent. Okay, awesome. There's 4 terms here. So we don't call this a quadrinomial or anything like that. So we have a monomial for 1, a binomial for 2, a trinomial for 3, and anything bigger than 3, we just use the general term polynomial. Okay, so even though a monomial is a polynomial, like we can still call 5x a polynomial. Okay, we usually call it a monomial because it describes how big it is. Okay, anything more than then 3 terms like 4, 5, 6, 7, we're going to call those just polys or polynomials. Okay, really not that big a deal. Okay, so the task for this section is to factor these polynomials. Okay, now remember, factoring is really just a fancy word for divide. Okay, when we are asked to factor a polynomial, we simply have to divide the GCF out of all the terms and write down what's left. We can always check our work by performing the reverse operation. So if factoring is dividing, if we just multiply, we'll get the original question back and we know that we're right. Okay, so let's try a few of these and see where we land. Okay, so completely factor the binomial and verify your work. So verify, of course, means check your work. Okay, so if we look at this, 4m and 12, what is the biggest number we can take out of both of those? Okay, well, the biggest number is 4. Okay, there's an m in the first term, but there's no m's in the second. So we can't take any m's out. So our greatest common factor is simply 4. So we write the 4, then just write brackets. So now we're going to take this 4 and divide by each chunk, each term in the original question. So 4m divided by 4, okay, is just m. Oops, sorry. Erase that. There we go. That's better. Okay, and then plus 12 divided by 4 is plus 3. And there you have it. So you go term by term and just keep dividing by that GCF and we'll factor the polynomial. So you get 4 bracket m plus 3. Now to check that we're right, this just multiplies, or your distributive law it's called. So 4 times m is 4m. Numbers and letters, they don't actually combine, they just string along. So the 4 and the m, usually we put the numbers first and then the letters, usually in alphabetical order, but it's not that big a deal if there's more than one. Okay, and then 4 times positive 3 is positive 12. Okay, and that is the original question, so we know we're right. So this is our answer, and then this part down here, that is the verifying. Okay, so little check marks, yay, we're right. Okay, so let's try this next one, 6g plus 3. Okay, so the biggest number we can take out of a 6 and a 3 is 3. Again, I can't take out any letter terms at this point because they don't all have letters. Okay, you can't take something out when you don't have it. Okay, so that's it. So 6g divided by 3. 6 divided by 3 is 2. The g just strings along. Okay, and then plus 3 divided by 3 is plus 1. Okay, now I didn't write the plus 1m over here. Now you could have, see I'm writing over here now. Okay, so you could have written the plus 1, but usually when you have a 1, if there's anything else, you don't need it. But in this case, 3 divided by 3, okay, if you don't put the 1 there, look, if you don't put the 1, you get the 2g, and then when you multiply, you just get 6g. Well, then what happens to the 3? Right, that would be a non-verified one. Okay, so you have to leave that 1 in there. Okay, so 3 bracket 2g plus 1. Then when you when you use distributive law, it looks like rainbows. Okay, so 3 times 2 makes 6g, and then 3 times 1 is plus 3. Hey, that's exactly what you had for the question, so you know that this is our answer. Awesome. So putting that 1 in happens anytime the whole term gets divided out. Okay, so we'll practice some more. So if you look at C, so at first glance this looks like a trinomial, but oh, look what I did to you guys. Okay, we have an 8d and a 2d, so those combine. So really this is 12d squared plus 10d's. Okay, awesome. So still a binomial. Now, what is the biggest number that divides nicely into 12 and 10? Okay, well, the biggest number that does that is a 2. Now, look at this next part, because this is different. This guy is d squared. This guy is d. So d squared is like 2d's, d times d, and d here is just 1d. So I can take a single d out of both parts. Okay, so that's good. So then we go 12 divided by 2 is 6. Now, d squared, 2 D's, divided by 1 D. Okay, that leaves us with a D. Okay, awesome. Now, plus 10 divided by 2 is plus 5. Okay, and you have a D. You divided a D out, or you factor a D out, so that's it. The D just cancels. So we go term by term. Okay, we do the numbers, we do the letters, and it's very, very doable. Okay, so this is our answer. Now, we'll distribute that back in and see what happens. 2 times 6 is 12. D times D is D squared. 2 times 5 is 10. And then the D, he doesn't have anyone to combine with, so he just strings along. So 12D squared plus 10D. Okay, that is our simplified original question, so that is verified. Awesome. So this really is our answer. Yay. All right, so now what happens when there's more than one letter? Okay, well, we go one at a time. So first things first, we're going to look at the numbers. So what number divides evenly into 14 and 35? Okay, well, the biggest number that does that is 7. Okay, so this first part has 2 A's, A squared. This next part has 4 A's, or A to the 4th. So the most I can pull out of both of them is A squared. Right? I can't pull more than 2 out of this first one because I only have 2. Okay, so A squared, so that's part of the GCF. So now we look for the B's. So there's 7 B's in the first one, 3 B's in the second one. So the most I can pull out of both is B cubed. Awesome. Okay, so that's it for letters. So then that's our GCF. So we just make our bracket. And now we factor, we divide. So 14 divided by 7 is 2. A squared divided by A squared is 1. But we've already got a number there, so we don't need to write the 1. Okay, and then we have B to the 7th, or 7 B's. We take out 3 B's. So if we have 7, we take out 3, we are left with 4 B's. Okay, awesome. So that's it for the first bit. Okay, and then plus 35 divided by 7 is plus 5. Okay, we have 4 A's, and we took 2 out, so we've got 2 A's left over, or A squared. We had 3 B's, and we took all 3 B's out, so that is done. Okay, if we distribute this to check our work, so 7 times 2 is 14. A squared with no A's just tacks on. B, so 3 B's and 4 B's makes 7 B's. B to the 7th. Okay, plus 5 times 7 is plus 35. 2 A's and another 2 A's is 4 A's, A to the 4th. And B cubed with no other B's, just strings along, B cubed. That is our question, so we know we are right. We have verified, and we are good to go. All right, so that's that page. Moving on. Okay, so let's use what we've learned to factor this particular trinomial. So I've got a 6, a negative 12, a negative 18. So the biggest number that comes out of all of those is a 6. Okay, so there's no z's on the 6. There's 1 z on the 12 and 2 z's on the 18. Okay, the 6 has no z, so you can't pull a z out. Okay, so that 6 is the GCF. So 6 divided by 6, so we factor, we divide. 6 divided by 6 is 1. There's nothing else, so we have to put the 1. Okay, negative 12 divided by 6 is negative 2. Now, the z, no z's factor out, so it's still 2z. Okay, and then negative 18 divided by 3 is negative 3. And the z squared just stays there as well. Okay, so that's what I'm thinking our answer is. Let's verify. So verifying is just using distributive property or distributive law. So 6 times 1 is 6. 6 times negative 2z is negative 12z. 6 times negative 3 is negative 18z squared. So that is indeed the question. So that is verified. So that really is the right answer. Okay, example 3, let's try something that's bigger. Okay, more than one variable, big. Okay, and again, these kind of questions, they look bigger, but it's you go one step at a time. Okay, we're going to do the numbers first, then the C's, then the D's. Okay, and we go one by one by one, and it's not so bad. Okay, so looking at the numbers. So negative 20, negative 30, negative 25. Okay, well, see how they're all negative? So we could pull a negative out nicely. Like I could have pulled a negative 6 up from up top, but one of them was positive, 2 were negative, so I didn't really worry about it. But here, all 3 of them are negative, so we might as well pull the negative out as well. Okay, and then 20, 30, and 25. The biggest number that comes out of those, okay, is 5. Okay, awesome. So we've done the number. Now look, the first term has c to the 4th. The next one has c cubed. The next one has c to the 1. Okay, so the most I can pull out of each and every term is c to the 1, or just c. Okay, then we look at the d's. This guy has d to the 1, d squared, so there's 2 d's, and then 1d again. So the best I can pull out of everything is 1d. Okay, there's no other letters, no other numbers, so that is my GCF. Okay, so we put the brackets. So now we just factor or divide. So negative 20 divided by negative 5 is positive 4. Okay, so I had 4 C's, I took 1 out, so that means I've got 3 C's left. I had a D, I took 1 out, so now there's no more D's. So that first term is done. So now we go to negative 30 divided by negative 5, and that is positive 6. So there's c cubed divided by c is just c squared. Okay, d squared divided by d is just d. There were 2 d's, you took 1 away, so now there's 1. Okay, so that's it for the second term. Now the third term, minus 25 divided by minus 5 is plus 5. Okay, you had a c, you took it out. Okay, so no more c's. You had a d, you took it out. No more d's. Okay, so that is the end of it. All right, so that's good. We're thinking that this is our answer, but we're told to verify. So we just use distributive property. Okay, so negative 5 times positive 4 is negative 20. Okay, there's 1c times c cubed, so that's c to the 4th. Okay, d with no other d's, just tax on. Okay, negative 5 plus 6 is negative 30. Okay, we have a c and a c squared, well that makes c cubed. D and d makes d squared. Okay, so that's it for that one. And then plus 5 times minus 5 is negative 25. Okay, there's no more c's, so he just strings along, and there's no d's over here either, so he just strings along. Okay, so negative 20 c fourth d minus 30 c cubed d squared minus 25 cd. Hey, that is the original question. So we have verified, which means that this really is our correct answer. Awesome. Okay, so another way to factor polynomials is with algebra tiles. And you should have worked with these before, but just in case, let's do some review. Okay, these big squares, okay, those are x squareds. Okay, the side length is x and x. Easy enough. Okay, these longer rectangles, those are called x tiles. They are x units long and 1 unit wide. Okay, and then you have the small squares, which are 1 tiles, and they are 1 by 1. Okay, so the area in here is just 1, because 1 times 1 is 1. Okay, 1 times x is x, and x times x is x squared. Okay, so the insides of the rectangles do represent areas. Okay, now your textbook, okay, they use that yellow is positive and that red is negative. Now I know your notes are black and white, so that's why I've labeled these yellow and red. Okay, so not a big deal, but now, just because your textbook labels them yellow and red, if you were ever given a legend or a key that tells you differently, then you use that, of course. Okay, but for now, and again, using your textbook, yellows are positive, reds are negatives, and then we're good. Okay, so let's try factoring these next couple, and then we're done for this section. Okay, for each arrangement of algebra tiles, write the polynomial they represent and identify its factors. Okay, so if we look at this, that's 1, 2, 3, 4, 5, 6, 7, 8. So those rectangles are x's, and then they're positive. So this is positive 8x. And then, oh, we have 4 red 1s. So that's going to be minus 4. So that's what the polynomial represents. And then if we factor this, okay, the greatest common factor is 4. So between 8 and 4, okay, the biggest thing we can pull out is a 4. Okay, the 4 has no x term, so we can't pull any x's out of him. Okay, so then 8 divided by 4 is 2. Okay, we had an x, we didn't pull anything out, so there's still an x. Then minus 4 divided by 4 is minus 1. Now if we look at what this means we have 4 groups of 2x minus 1. If you look at that, we really do have 4 groups of 2x minus 1. See how there's 4 separate groups of those? Okay, so factoring, grouping, dividing, they're all the same word. Okay, so now let's look at B. Okay, oh, sorry, so the factors of, we have to identify its factors. So the factors were 4, and then the bracket part 2x minus 1. So those are the factors. Okay, so we look at this guy. So these are x squared terms. So there's 4x squared, okay, and then minus 4 x's. And then 1, 2, 3, 4, 5, 6, so minus 6. Okay, so that is what the factor tiles represent. Now, if you look at all of these, the GCF here, 4, 4, and 6, the greatest common factor is a 2. Not everything has an x in it, so I can't take any letters out, so that is the GCF. So then we end up with, okay, 4 divided by 2 is 2, so 2x squared. Negative 4 divided by 2 is negative 2, okay, divided by, x, we didn't divide by any x's, so it's just 2x. And then negative 6 divided by 2 is negative 3. So again, what this means is we have 2 groups of 2x squared minus 2x minus 3. So if we just divide here, right there, okay, we take 3 of these things, we'll just cancel those off. So you get 1, 2, 3, and you know what, I can write in red because, you know, I can. So there's one, it's not the same red, but you guys get the idea. So see how there are 2 equal groups, okay, of one with 2x squareds, with 2 x's, and minus 3 dots. So factoring, dividing, grouping, they're all the same terms. Okay, so I'd like you guys to practice this section. It is section 3.3 in your textbook. Okay, starting on page 155, so I'd like you to do these questions. Remember, if you're feeling like you need to do more to get this stuff, like you can always do more. Okay, but these are the ones you have to do. Remember, the answers are in the back of your textbook. Okay, and make sure you show your teacher when you're done so they can let you go on to the next part. So, good luck, and we'll see you next part. Thanks.